Yes, this is second lesson on probability. Okay. We will continue study probabilities. Okay, probabilities is basically just if you know how to count, then you should be able to find the probability. Okay. So let's do some exercise. Right. So my first problem I will be the following: a 4-digit number is created using the digits 1, 2, 3, 4, each ones. What is the probability that the number is odd? Okay. So a 4-digit, you can start to work on that. A 4-digit number is created using digits from 1 to 4, each ones. And what is the probability that the number is odd? Okay. All right, so you're going to create a number, right? It's a number such like 2, 4, 1, 3. This is the number. It's odd, right? Clear. Right, so how do you figure out the probability? Denominator, the number of all possible outcomes. The number of all possible outcomes will be 4 factorial. Why? Because you can permutate those 4 numbers, 4 digits, right? Permutate for 4 digits. So you get 4 factorial different 4-digit numbers you can get. Now you only focus on other numbers. So how do you make sure this other number? You have, right? So first of all, you have to figure out the units digit have to be determined first. You only have 2 choices, 1 and 3. Okay. So step 1, choose a units digit. Then you can guarantee it is other number. So there is only 2 choices. Okay. Then for the remaining 3 digits, you can permutate them. You can put them in any order. Okay, that will be 3 factorial. Okay, so the answer will be 2 over 4, which is going to be 1/2. Okay. Yeah, good job. Okay. So our next problem will be slightly different. It's about number series. Like 5-digit number is created using digits from 0 to 4, each one. What is the probability that the number is odd? Okay, this will be a little bit more complicated. Okay, a 5-digit number is created using those digits. Okay, each ones. Okay, what is the probability that the number is odd? Okay, so now we're going to get some strange numbers. I'm waiting for a correct answer. That means the answer I got from Alan, from Tobias, from Liping. Who is Liping Chan? Okay, okay. So I'll give you a little bit more time to think about.
Oh,
Any different answers? Sophia? 2/5? All right, so let's figure out what is the number for all possible outcomes. Okay, number for all possible outcomes. Okay, you're going to write down 5-digit numbers, right? The 5-digit numbers, you begin with the first one, right? So clearly you cannot use a 0, so only have 4 choices. Then for the remaining 4 digits, you can randomly put them in a row. So it's 4 factorial, meaning just one by one, all together. Yeah, that's right. So 0 cannot be the first digit, but you can have 1, 2, 3, 4. Any of this digit can be used for the first one. Okay, so this is going to be the number of all possible outcomes. It's going to be the denominator. Okay. Now the number of all design outcomes, that's the outcomes you want to see, right? You have to make sure it's odd, right? So how many digits there are? Odd digits, just either 1 or 2. So you can choose 1 or 3, sorry, 1 and 3. So first of all, you get 2 choices, right? You put 1 or 3 in the units digit place. Then, how many digits left? 4. 4 digits left, okay? 4 digits left, and including 0, okay? 0 is not used yet, okay? Including 0. 0 is not used yet, okay? But be careful. Then next step, you have to choose the one for the first digit, right? Choose the digit for the first place. And then you cannot use 0. You have 4 digits left, so that's only 3 choices, okay? Then for the remaining digits, you can put at random for the 3 places. So that will be 3 factorial. Okay? This is a guarantee. The first digit is not going to be 0. The last digits will be odd, right? Now you simplify it. You will get 4 times 4 factorial, 2 times 3, and 3 factorial. And you will get 2, 3, 3 factorial, 4, and 3 factorial, and 4. So 3 factorial canceled out. And after you simplify the 3 over 8. Nobody got 3 over 8, unfortunately. 3 over 8. There's no 5 there. You cannot get 10. All right? Yeah. You have to make sure that the desired outcomes, right? The first digit cannot be 0. The last digit cannot be even. Must be odd. So you have to pick up the digits for the first one, for the last one first. Step 1, step 2. Okay? You have to pick up the digits for the, I think for the last one first, because you have to make sure it's odd integer. Okay? There's only 2 choices. Then you have 4 digits left, including 0. 0 is not used. Then for the first one on the left, right? You cannot put the 0 there, so you can have 3 choices. That's why it's a 3. Then for the remaining 3 places, you can randomly put any of the digits, what is left. Okay. All right, so now next problem. Next problem is what is the probability of lowering a sum of 7 by tossing 2 fair dice. All right. So you don't know what's wrong with this? Let me check what they got. Right? You only give me the answer. You did not tell me how to get that. Okay, I already explained to you. You have to make sure, guarantee, you know, this 4-digit, this 5-digit number, the last digit must be odd. The first digit cannot be 0. Okay. So anyway, so this is so you're going to toss 2 dice. You can do that one by one, but you have to record the 2 numbers, right? But make sure the sum is going to be 7. Okay. Yeah. Okay. Vincent, I got your message. Right. So now we got, right? So everybody got 1 over 6. So this is the question. What is the probability of rolling a sum of 7 by tossing 2 fair dice? So so you can, yeah, the probability, the denominator. Let's look at the denominator. The number of all design outcomes. You have 2 dice, right? So you have 2 dice, and for the first one, you have 1 to 6 choices. For the second one, you also have 6 choices. So that's why you total get 36 numbers, ordered numbers, right? So those things, yeah, 3, 1, 3, those are 2. Those are 2 numbers, right? And the 3, 1 is also, we view them different. Okay, so the sum is not going to be here. The sum is 4. Then we are going to count those who give you the sum of 7. Right? That not meaning that if the first one is 1, then the second one must be equal to 6. If the first one is 2, the second one must be 5, and so on. The first one is 6, the second one must be 1. The second one is completely determined. You have no choice because the sum is going to be 7. So total, you have 6 choices there. Okay? You have 6 choices there. So that's why, right? 1, 6, and 6 1 would be different here for you. Okay? So the answer will be 1 over 6. Okay, got it? Yeah. We write down 2 numbers in the order, okay? 1 by 1, right? We write down 2 numbers 1 by 1. And those 2 numbers can be only selected from 1 to 6, okay? So the total number of outcomes will be 6 times 6 because there are 2 numbers you write independently, right? So 6 choices, total 6 times 6. But the desired outcomes must be, the sum must be 7. So then you only have 6 different choices. Okay. All right. So that's why you got the 1 over 6. Now my next question is, we are going to have from let's do the next one. Okay, 3 slips of paper labeled A, B, C. Okay, those are drawn from a drawer, from a box. Okay, we are going to have here A, and B, and C. Okay, so 1 at a time, 1 by 1. Okay, 1 at a time. So 1 by 1, without replacement. Okay, So what is the probability that the join A last? Okay, so the last one would be A. What is the probability? Huh, Vincent, great. So you said it's 1/3, right? Are you sure? Okay, how do you do that, right? And this one by one, right? One by one, you write down these 3 letters. Okay, I have the probability right here is the number of all possible outcomes will be 3 factorial. Okay, but the number of the desired outcomes, be careful. The last one must be A. Okay, no choice because the last one must be A. Then how to draw the letters for the first two places, right? And that's only 2 choices, right? BC and CB. So that's 2 choices. So after you simplify, you will get 1/3. Okay. Now if I change your problem a little bit, suppose the same problem, but the box contains A, B, C, D, E, F, G. How about this? Okay, but this time I'm going to draw 3 letters, from the box. What is the probability the third one is A? Draw 3 letters from the box. Containing A, B, C, D, E, F, G. Okay. What is the probability the third one is A? All right. Yeah, draw 3 letters from the box and one by one. Of course, there is order here, one by one from the box. Let's do the computation. Okay, it's 1/6, 1/7. Maybe, maybe not. Okay, so let's look at the number of all possible outcomes. Okay, you're going to have 3 letters, right? One by one. So that's going to be total 1, 2, 3, 4, 5, 6, 7, 7, then 6, then 5. This is a product of 3 numbers, right? This is the number of all possible outcomes. Okay. Okay. Then the number of designed outcomes. How to make sure the third one is A, right? Right? You have to choose put the A here directly, no choice. Okay, right? No choice, just say. Then for the first one, for the second one, you can pick up any number you want. So there are 6 left. 6 left, they have 6 choices. Then for the second one, you have 5 left, right? So you have 5 choices. Okay? So the answer will be the ratio of these 2 numbers. Okay? So that's why it's going to be 1 over 7. Good job. Right, the next problem. What is the probability of rolling 3 dice and getting the same number on the top of the 3 dice? Tossing. Hmm? Okay, so what's the probability you will get 1, 1, 1, for example, right? Okay. Yeah. So the probability will be, the denominator will be 6 times 6 times 6, right? Each time you have 3. Write down all the possible outcomes, right? The number of all possible outcomes will be 3, 6 times 6 times 6. Then the numerator, you have to make sure the numerator is, you do have a 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, right? Total that was 6. Okay, so the answer is 1 over 36. Right. All right, so now the next problem, not everybody can do it, but I will be patient to wait for your answers. Okay, we have 3 boys, 2 girls are to be seated in a row of 5 desks. What is the probability that the students at the end of the row are both boys? 3 boys and 2 girls, okay, are to be seated in a row of 5 desks. Okay. What is the probability that 2 boys are the 2 endpoints? Nope. All right. So you're going to arrange seats for the 5 students. 3 of them are boys, 2 of them are girls. But you have to make sure their boys are seated at 2 ends. Okay? Any answers? Alan, you got 3 tenths. Henry. Any different answers? Oh, 1 over 20. All right, let's do the problem. Okay. We're going to have a 1, 2, 3, 4, 5, 6. I have to make sure boy is here, right? So you want, yeah, first of all, okay, the denominator, they're going to be 5 kids randomly sit there, right? So it will be 5 factorial, no question about this. The numerator is the number of desired outcomes. In order to, you cannot randomly put the 5 kids there, right? So you have to put 2 boys at the 2 ends, okay? So you have to put one boy on the left-hand side, but you put a boy from on the left-hand side, you have 3 boys to choose, so there'll be 3 choices. Then you go to the right-hand side, then only 2 boys left, so you have 2, okay? Then the remaining students, 1 boy, 2 girls, can be sit randomly in, yeah, so it'll be 3 factorial. All right, so now after you simplify, 3 factorial canceled out, the answer will be 3 over 10.
No.
Okay? Okay, my question is still about problem. What is the probability that girls and boys sit alternately? What means they cannot be sit together, okay, they're separate. Okay? Yeah, you still have 3 boys, 2 girls here. Yes, yeah, they cannot sit next. All right, so 3 boys, right? The only possible pattern is this, right? That, yeah, the boys cannot be next to each other, the girls cannot be next to each other. Okay, so what is the probability? 1 over 10, right? The denominator is still 5 factorial, right? The numerator, the pattern is fixed. All you have to do is just permutate 3 boys, right? And you have to permutate 2 girls. So that is the numerator, okay? Then that will be 3 factorial 2 and 3 factorial 4 and 5 canceled out. It's getting 1 over 10. Okay, 1/10. All right, my next question is, if, all right, let me see. I'm going to choose a couple names, okay? If Aaron and Grant are among them, okay? That's the condition, okay? What is the probability, if you randomly put them in a row, what is the probability that Aaron and Grant sit next to each other? Okay, this is it's a little bit harder to figure out than enumerate. Okay. Please do this problem. So right now, the three boys, Alan and Grant among them, right? Then you randomly put them in a row, right? 5 students total. What is the probability that Alan and Grant sit next to each other? Yeah, please do this problem. Any answers? Come on, Vincent, you have to give me a definite answer, okay? The 2/5, Grant says. 1/5. 1/4. Come on, this is not 2/5. Catherine. Oh, when did they show up, Catherine? I did not see you. Let's see. Oh, you came late. You joined late, okay? Let's see. So we have more students claim it's 1/5, right? But this is not an election of president. Okay. More votes does not mean always correct. Let's see. Okay. So let's figure out the number of design outcomes, right? When you do the computation. So there are two possible patterns, right? Alan and Grant, right? So we have Alan, Grant, right? That's one possible, right? And then Alan Grant, right? Then star AG, star, then and just so on, star AG. Okay. Another pattern will be just switch it, you know, GA. So okay, so those are the patterns. Okay, either in this or that position. Okay, so clearly it is going to be, I think, for in each case, you just permutate as a 3 students, 3 factorial. But how many groups here? 6. No, 1, 2, 3, 4. Okay, 4, right? I have four groups here. So for each group there are 3 factorial many permutations, right? So the probability will be 3 factorial times 4 and 5 factorial. Got it? So the answer will be 105. Why? Because 3 factorial times 4 is 4 factorial, 5 factorial is 4 factorial times 5. It's 105. Right? Right. Our next question is, 3 boys and 3 girls are to be seated, no, in 2 rows. And this is the left row and the right row, okay? So let me, but that mixture, you know. Yeah, this is the left, this is the right, okay? This is, you know, 2 rows. Okay, what is the probability that 3 girls are on the same size? If you randomly put 6 of them in a row, what is the probability that yeah, don't think, you have to do the computation. Okay? Vincent, you have to figure out what the denominator was the numerator. Looks like you, yeah, I don't know how to do it quickly, so quick. Okay, 6 students put in a row, there'll be 6 factorial, many different choices. Okay, the difficult part is the numerator. Okay. Wow, 1/2 and 1/120 is a very huge difference. Probability. Jonathan, please use a pencil, work on the problem.
Yes, sir.
Any answers? Any different answers? First of all, you have to look at the pattern, right? Girls must be on the same side. So there are 2 possible patterns. And that's a boy, 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 and girl, and girl. But there's another possible pattern. Okay, got it? That's my hint. So first of all, you look, yeah, you look at the puzzle patterns, right? So those are puzzle patterns. And 3 boys on the left, 3 girls on the right. But 3 boys, how do you do that? How do you make arrangements, right? You just permutate them. So it'll be 3 factorial, many. And then you also have a 3 factor many permutations for the 3 girls. That's for the first pattern. For the second pattern, you also have this many. Okay? Why it's product? Because these are 2 independent steps, right? Put 3 girls on the left, put 3 girls on the right, 3 boys on the right. And but how do you put 3 girls on the left? You have 3 seats there, 3 girls, so that's what 3 factorial many. 3 factorial many arrangements. Right? Yes. So now you can compute it. It's 2, 3 factorial, and the 3 factorial, 4, 5 and 6. Let's cancel this first. And 3 factor is 6. I cancel that. And then just 1 over 10. Okay. All right, so next question. Okay, 6 students are to be seated in 2 rows, left and right. Okay. Okay. So 1, 2, 3, 1, 2, 3. Okay. So what's the question? Among them are Aaron and Grant. Okay. So what is the probability Aaron and Grant are sitting on the same side? All right. So the denominator is going to be definitely is going to be 6 factorial, right? How do you figure out the numerator? So if you are the teacher, right, you want to put 6 students in a row, you have to make sure Aaron and Grant sit on the same side. What you should do, right? How to guarantee those 2 students will be on the same side. Of course, you will let Aaron and Grant go to pick up seats first, because otherwise you find out when Aaron arrives later, they say, oops, where's my seat? You know, there's only 1 seat left for him, which is on the other side, right? Of Grant, you know, Grant maybe sit on the 1 side already, and no seats. Other 2 seats are occupied by other 2 students. So if Aaron comes late, there'll be no seats on the same side as Grant. Okay, that's my hint. Okay, so please do that. Come on. Y'all get 3 different answers: 1/5, 2/5, and 1/3. Any different answers? Catherine Young. All right, so you're the teacher, right? You want to make sure Aaron and Grant sit on the same side. How do you do that? You can ask Aaron, please go ahead to pick up seat. How many seats Aaron can choose? 6. Then you cannot let other students pick up seats. You have to make sure, you can let the 1 student pick up a seat, but definitely you should let Grant to pick up seats, right? It's a better second step. So for Grant, there are only 2 seats left on the same side of Aaron. It's 2. Then for the remaining 4 students, they can randomly pick up seats. Okay? On the remaining seats, there are 4 seats there. So you have 4 factorial. Okay? So the answer will be 6 factorial is going to be 4 factorial times 5 times 6. Cancelled out, cancelled out. That'll be 2/5. Okay? You got 2/5. All right, so let's do the next one. Two Chinese and 2 Americans are to be seated in a row. And what is the probability that Chinese sit together? All right. You know, I can change the problem like to 2 Chinese,
Sure.
5 Americans, for example. Right? So 4 people randomly put in a row. What is the probability that the 2 Chinese sit next to each other? There's not many people there, just 4. Yeah, the 4 chairs, right? 4 chairs. Hmm? And then 2 Chinese, 2 Americans, right? Yeah, Henry is got 1/3, Grant got 1/4,
I got 1/3.
1/8.
1/3.
Ha, come on.
No.
Tobias says 1/3. Amy says 1. Oh, so many people jumped to 1/3. 1/8. Okay.
I got 1/3.
Can you redo the problem? Okay, I haven't seen the correct answer yet. Don't guess, okay? You have to give me a reason, the number of design outcomes. The denominator clearly is going to be 4 factorial. It's not a 2 here, right? It's 4 factorial because there's 2 Chinese are different, right? 2 Americans are different. So that's be 4 factorial. Okay? Kathleen, I don't think you can get a 8 denominator. Or 2 times 4 is 8, maybe. Let me wait until somebody give me the right answer. Okay, 4 seeds. All right, so let's look at the possible pattern. Two channels must be sit together. So 2 to AA, right? That's one possible pattern. Then ACCA, AACC. Got it? The 3 different patterns. Okay. So for each pattern, you have 2 choices and 2 choices for Chinese. Right? And then you have 3 different patterns there. Just add 2, 2 plus 2, 2. So the answer will be 2 times 2 times 3, right? 1 times 2 times 3 times 4. And that cancels out. It's going to be 1/2. There are 50% chance 2 Chinese sit together. Come on, right? First of all, you determine the possible patterns. And for each pattern, you figure out how many arrangements. Then you solve the problem. Okay? Okay, so let's do next problem. Say 3 Chinese and 5 Americans to be sit in a row, right? What is the probability that the people of the same nationality sit together? There are 8 chairs, okay? Yeah, 8 chairs. Okay. That one, yeah, and one more, okay? So Chinese and Americans should sit this. The people of same nationality sit together. Okay, what is the probability? Well, the denominator is still is going to be 8 factorial, right? The numerator, just count the number of possible arrangements so that 3 Chinese sit together, 5 Americans sit together, right? Come on, any more answers? Do you understand? Felicia, you're getting close. Another correct answer, okay? Felicia, Chen, you got some ideas. All right. First of all, I have to figure out a pattern, right? Chinese must sit together, American must sit together. So possible pattern is CCC, AAA, or AAA, CCC. That's only two patterns. Clear? Cannot be mixed up. If I just say American must sit together, then that's a bit different. But now Chinese and American must sit together. They're separate, right? These people with same nationality must sit together. All right, so there are two patterns. For each pattern, how to make an arrangement for Chinese, the 3 factorial main choices. How to make arrangements for Americans, 5 factorial. Then you switch to the next one, 5 factorial and the 3 factorial. That's it. Then you simplify it, and you will get what you want, okay? So it's 2 times 3 factorial, 5 factorial. 8 factorial is 5 factorial, 6, 7, 8. So cancel these. 3 factorial I know is a 6. So, and so it's 1 over 28. Yes, 1 over 28. Only Grant gave me the right answer this time. Yeah, I think Felicia got idea, but you forgot, you know, Chinese on the left, Americans on the right. Then you switch it. The 2 possible ways to make arrangement. So there are 2 steps here. Step 1, you have to tell Chinese or go to left, or American go to right, or switch. Right, that's a step 1. Then among each group, you have to permutate them. Got it? So step 2, you permutate the Chinese or permutate the Americans, and then you get different arrangements. All right, so last problem we're going to do is the following, okay? Then D is selected at random from 0 to 3 all the way to 9, okay? What is the probability that the 4-digit integer, okay, 23 and 23 and 2D is divisible by 4. Got it? So this 2,320 something is divisible by 4. I give you 1 minute, then I explain to you. Okay? We are almost at the end of the class. Come on, I want to see 1 correct answer from you guys. I'm seeing some correct answers on the list, but surprised to me get so many different answers. Okay. All right, let's see. So 2,320 something is giving 2,300 plus 2D, right? So this is always divisible by 4. Don't worry about that. Right? 100 divided by 4. So 2D's divided by 4 if and only if if unknown if D is going to be 0, because 20 is divided by 4, and 4 and 8, right? Every time you increase by 4. So the answer will be, the probability is, it's a 3 on the top, right? 3 on the top, but how many digits do you have here? 10 digits. So 10 digits. That's it. This is the answer.